You want to set it up so you have the number of resistors that are in your circuit. Here we only have 2 resistors, and you want to leave a space for total resistance, total current, total voltage. You want to start out by plugging in everything you know, and this is all I'm going to give you. So we have 10 ohms, we have 8 ohms, and we have our total voltage, which is 9 volts. So start where you have the most information and work it out. Okay, so you could pause the video if you're still working. So I said start where you have the most information. You have the most information right here. You have both of your resistors and known resistances associated with them. So the first thing I would suggest doing is finding REQ, or R total. So step 1, REQ is equal to R1 plus R2. This one's much more manageable than the last one that I gave you. So REQ is equal to 10 ohms plus 8 ohms. Because we know that in a series circuit, the more resistors I add in, the more the resistance will increase. So it has an additive effect. So REQ in this circuit is going to be 18 ohms. So let's write that in. Now that you have this piece of information, you actually have the most information right down here. And we can actually solve for our total current in the circuit using Ohm's law. So the next step I would say is to do V total equals I total times REQ. In other words, we have a 9 volt source, an unknown current, and 18 ohm resistance. So obviously our current is going to come out to be 0.5 amperes. And while that doesn't seem like we've made a lot of progress, we actually have, because we know that what is special about the series circuit is that the current is the same everywhere at each point. So whether I put the ammeter here, whether I put it here, whether I put it here, it wouldn't matter, because at all of these points I'm going to get a reading of 0.5 amperes. Since the current only has one singular path to take, it's not being split. So let's take that 0.5, let's fill it in over here and over here, and let's express that in a formula. So let's say, by the way, we know I total equals I1 equals I2, which is equal to 0.5 amperes as we previously calculated. This is how you would show your work for that. Okay. Last thing that we can do is find the voltage drop across each of these resistors. So I'm going to go ahead and multiply my current times my voltage for each of these. So 10 ohms times 0.5 amperes is going to give us 5 volts. 8 ohms times 0.5 amperes is going to give us 4 volts. And this checks out beautifully because we know that our total voltage should be equal to the sum of V1 plus V2. So what's really happening here is we have our high voltage end, which is 9 volts. We have our low voltage end, which is 0 volts. And across resistor 1, this thing is stepping down 5 volts. So 9 minus 5. So this voltage V1 is 5 volts. So on one end of this we have 9 volts, and we've stepped down 5, so we have 4 volts on the other end. Resistor resistor 2, you don't need to know this, by the way. I'm just trying to give you a full description of what's going on. Resistor 2 has a voltage drop of 4 volts, which is perfect because we know that on the high voltage end we have 4 volts, and that's going to bring us all the way back down to 0, completing the flow of current through this circuit. Okay. So again, we would want to show our work, so we would want to say V1 equals I1 R1. In other words, I can't remember the resistance, 10 ohms and 0.5 amperes. So 0.5 amperes times 10 ohms, which we said is going to be 5 volts. V2 is equal to I2 R2. So we have 0.5 amperes times 8 ohms, which gives us 4 volts. And finally, our way of checking, we say V total equals V1 plus V2, which is going to be 5 volts plus 4 volts, which does add up to 9 volts, which we knew to be our total resistance.